This is John Black, Super Chemist. I did a video called How to Get Anhydrous Ethanol, and how to get videos of just talking, how to get it. This one I'm actually doing it. Basically, I got 4 of these 1 liter 40% by volume vodka. Got 4 of them. Distilled them out, and that got me this. Now, this bottle was a 1,750 milliliter bottle, but I only had to fill it up to about right here. So there's probably 100 milliliters there. So say I had 1,650 milliliters. I got a density of 0.8250, and that took that 40% by volume up to 91.8% by volume, which is correlates mass percentage is 88. So I'm close to being the azeotrope. I took out 500 milliliters. I put it in there, and now I'm going to distill it a second time. The reason why I'm not doing it all, or 1,000 milliliters, is because I'm going to save this and do it cooks in my how to get video. I tell several different ways to get it. Like, you can cut the azeotrope out by going below 70 torrs or 70 millimeters of mercury, whatever you want to call it. But if you take the pressure down to that low, you'll get rid of the azeotrope. You can distill it better. Potassium carbonate. There's a couple other ways. But anyways, I'll take this and I'll try a couple other different methods. This is the nice, easiest way, or maybe not the easiest, but the one I know the best. The first distillation was done with the same exact setup. The only difference was this was over here, because I was doing 1 liter at a time, so you need a 2 liter flask, and that's what this is. But you can see I'm going to distill it a second time. I'll do another density reading, and then we'll use molecular sieves. Because I bought these sieves like 2 years ago. You can see it's boiling up there. We get a good look. There's the receiving flask. It's not going super slow. First distillation, I went quick. I'm amazed I got that good of a percentage. I thought I'd get like 80% or something, because I was going so quick with it. So there's just so much. I mean, there's a lot. So anyways, when I get this done, the reason why I use the big flask here is because I'm running out of flask. Basically, the only one I have is these 2 right now. Anyways, when I get done doing this, I want to finish this up, and we'll see what I got. Well, it took long enough. I left that much in. It's probably only 50 milliliters of water in there, but it's so low. I mean, it's probably there's up 100 milliliters in there. Say half of it is alcohol, half of it's water. Now I'm distilling from a 50-50, 50%. So I don't want to screw up my thing over here. I don't know if you can see the line that's right above where that thing is here. Watch me. See it? Right above there. So that should be 95. I mean, or whatever the azeotrope is. I'm going to do a density test and we'll see. Let's do a little bit of math there. I started out with 500 milliliters of 91.8 or 88%, depending whether you're doing volume or mass, of ethanol, right? Now we know that the density, because I took a density test, was 0.825. So I multiply this by 0.825 to find out how many grams I got, right? Because this is grams per milliliter. The milliliters cancel out. You end up with 412.5 grams. Now we can't do the volume one because the math won't work out right. You got to do it by mass, okay? Because if you add 500 milliliters of ethanol and 500 milliliters of water together, you do not get 1,000 milliliters of mixture. You would get a little bit less, okay? So you can't use volume, you got to use mass. So we have mass. Now we have 88% ethanol, so that means we have 12% water, so I took that by 0.12. I got 49.5 grams of water. The density of water is 1, so 49.5 grams equals 49.5 milliliters of water, right? Now the ethanol, right? I'm going to start out with the same mass, 412.5. This time we're going to times it by 0.88 instead of 0.12, right? We got 88% of the ethanol. We end up with 363 grams of ethanol in that 500 milliliter mixture. Now we want to change that to milliliters, so we divide by density, right? Milliliters cancel out and you end up with grams. I mean, the grams cancel out and you end up with milliliters. So there's 460 milliliters of ethanol in this 500 milliliter mixture. And there's also 50 milliliters of water in this 500 milliliters mixture. Now, if you add up 460 and 50, you end up with 510 milliliters total, right? But when you mix them together, that 510 condenses down to 500. That's why you can't do the math with the volume. There's no sense. So anyways, my whole point is that there was almost 50 milliliters of water in this pot when we started out, and I ended up with 60 milliliters in the pot, okay? So when I distilled the stuff over, it wasn't azeotrope, so I did distill out like 5 milliliters of water. So say there's 45 milliliters of water in here and 15 milliliters of ethanol. So I lost 15 milliliters of ethanol, right? So I did a pretty good job on getting this out. Didn't lose that much ethanol. Yeah, I used this graduation tube, or graduation cylinder. Did a density test. I got a density of 0.802, and the density that I should have got was 0.804, so that's pretty much right on the money. So let's move on to the next step. Alright, there's my ethanol. We got 160 grams of sieves. Alright, so how many sieves do I need? Well, I distilled out about 450 milliliters of stuff, right, of azeotrope ethanol, right? I didn't measure it or whatever. It's about that. It doesn't matter because I'm going to add extra. The density was 0.804. That's what the density is for azeotrope. I think mine was 0.8042 or something. It was like exactly the same almost. Anyways, so I got 361.8 grams. Okay, that 450 milliliters weighs 361.8 grams. Now, we can't use volume, remember, we got to use mass. There's 4.4% left of water and 95.6% of ethanol. So we took 44.4%, which is 0.044, and we got 15.92 grams of water, or 16 milliliters. Because a gram is, it'd be 15.92 milliliters, and we jack it up to 16 to have a nice rounded number. Molecular sieves, in general, if they're good, they should be able to absorb 1/5 of their weight, right? So I took this 16 milliliters and I times it by 5 to get 80, okay? Just to make sure, I took 80 times 20%, right? Because they can soak up 20% of their mass, is 16. So 80 grams of good molecular sieves will soak up 16 milliliters of water, and that's what we got, right? So I need to add 80 grams of molecular sieves. Now I'm going to use 160 because these are old. They've been sitting there for 2-3 years and they've never been used. I've never regenerated them. I'm sure, in the factory they soaked up some water and while they were sitting there, you know what I mean? they were in a plastic bag, so it's not like they, you know. So I'm going to add in 180 grams, or 160 grams. Keep in mind, you want to put this in a bottle that has no extra. I got too big of a bottle there, because this has air in it, and air has water in it, which means you're going to just be soaking up that water or whatever. Okay, this is ridiculous how many sieves that is. Jeez. Spin it around a little bit. So that's it. Basically, you can either redistill this. You know, you got particles of the molecular sieves in there. You might want to filter it out. Or once it sits, you know, drop to the bottom and you can just decant it. You know, whatever your thing is. Let's recap. Started out with 4,000 milliliters of 40% by volume ethanol, right? I distilled it real fast with a vigorex column at 80 degrees Celsius for about 22 hours and got 1,650 milliliters of 91.8% by volume ethanol. I took 500 of that, 500 milliliters of that, right? And I distilled it with a vigorous column between 77 and 78 degrees. And I got about 450 milliliters of azeotropic ethanol. After that, I added 3A molecular sieves, 160 grams of them, even though I only needed 80 grams because they were real old sieves. So anyways, I let that sit for 3 days, filtered it out, and there you go. Anyways, y'all have a great day. Always remember, science is great. I just wanted to show my Bunsen burner I got here. Check this out. See, blue flame. See that? And this here is just from a pancake regulator and a hose from a grill, a gas grill. I just cut it off and put it on there. You know, I need a longer hose, obviously. But see there? Pretty nice. Now I can turn it down to the orange flame. I need 2 hands to do it though, but oh, there we go. Let's do the opposite here. There. Got my cool flame. Got my blue flame. Hot flame. Anyways, just want to show you that.